Hello, we are going to discuss Cambridge syllabus uh, CIE 9702/13 October November 2016 paper. This is paper 1 multiple choice question paper. Um, First of all, let me share the screen. Yeah, here we go. So this is a 1 hour 15-minute paper. So there are uh, 40 questions, as you can see, and you have to spend your time wisely. So let's go to question number 1 straight away. What is the order of magnitude of the Young modulus for a metal such as copper? So before attempting a question of this sort, first of all, you need to have a proper understanding as to what Young modulus means. If you have difficulties, if you do not know what Young modulus is, so that is going to be a problem. So initially what you need to do when attempting a question of this sort is always try and refer to the textbook. The textbook will give you all of the information that is needed, and this will help you in trying to understand the question and of course finding the answer for the next stages. The Young modulus, I will again share the textbook with you. So this is the part which contains all the details about Young modulus. So let's go through it first. The stiffness of the material we are stretching. So that is what we are talking about in Young modulus. Young modulus refers to the stiffness of a material. Rather than calculating the ratio of force to extension as we would for a spring or a wire. Now in a spring or a wire, what we do is we can actually stretch that. If it is a spring, we can stretch it, obviously. Then wire also can be stretched. That is how we find out how stiff or the properties of that could be found by using that mechanism. We calculate the ratio of stress to strain. So in that one, in a wire or a spring, we talk about the extension. But in another metal, so not all the metals, it is not fundamentally easy for us to make them into springs whenever we want. So what we can do is we can test the stress to strain ratio. This ratio is a constant for a particular material and does not depend on its shape or size. The ratio of stress to strain is called the Young modulus of the material. So remember, we are still talking about stiffness. So Young modulus is stress over strain, and there is a chart that you will have to remember. This chart, Young modulus against material. So as if you look at the chart from a fundamental point of view, you will be able to see that metals such as steel, brass, and the harder the materials, iron, wrought iron, these have a very high value for Young modulus. The other materials, when the stiffness, we can practically get an understanding as to how they are. Less strong or stiff they are, the Young modulus decreases. As you can see, rubber has the lowest Young modulus here, being 0.01. Then look at glass. Glass could be stiff, so it is 70 to 80. So that is something that we have to bear in mind. So again, Young modulus is equal to stress over strain. Then sigma over epsilon is the Young modulus. That is how we find it. Stress is measured in sigma, and strain is measured in epsilon. Um, then Young modulus has the same units as that of pressure, newtons per meter squared or pascals. Now here it has, in this chart they have referred to the units in Young modulus in GPa, that is gigapascals, because it is easier to write it that way. So it is quite high, as you can see. So if we are to present this on a graph, we can stress over strain, and stress is established in y-axis and strain is shown on the x-axis. Stress y, strain x. Then the gradient of the line that is drawn would provide us the Young modulus. And the point beyond which the gradient isn't the same, that is where the Hooke's law is no longer obeyed. So in the linear region, the Hooke's law, just as we saw in the extension graphs that we used to draw, whenever it doesn't revert back to its original position of a spring, we say that beyond that Hooke's law is not obeyed. So the same thing applies here. Hooke's law will not be applied beyond this point. So in the linear region, Hooke's law is obeyed. So that is the understanding that we need to have about Young modulus. So Young modulus is measured in, to go back, stress is force upon cross-sectional area. Those things you need to know beforehand. So Young modulus is measured by dividing stress by strain, that is sigma by epsilon, and the units of Young modulus units are similar to that of the stress, that is newtons per square meter. That is in again, which is similar to pascals, or pressure, the units of pressure. So to answer our question at hand, the question is, what is the order of magnitude of the Young modulus for a metal such as copper? So we need to have a thorough understanding about this chart. Even still, if we do not remember the chart, we will be able to get an understanding by just looking at the values. So obviously here we can get rid of the answer A because it has no connection whatsoever with the understanding that we have, because it is 10 to the power minus 11 pascals. That is very, very low. And again, this is also we can get rid of. And 10 to the power 4 pascals, again, it is quite low. It is lower. 10 to the power 4 is 10,000 pascals. So that is not going to work. 10 to the power 11 pascals, because we were talking about 200 gigapascals in our earlier session in the chart. So it is 10 to the power 11 pascals. That is going to be our answer.